Dear students, very good afternoon. Today we are going to discuss our third problem. Our third problem is if u equal to a, okay, if u equal to a cos h, this is hyperbolic function, a cos h of x. Okay, here x is the angle, cos h itself is the single trigonometric ratio, okay, similar to sine. Okay, so this cos h is a hyperbolic function. Okay, so similar to cos, we will have cos h. Okay, so u equal to a cos h x into cos y comma v equal to a sin h, a sin h x into, okay, sin h x into sin y, then so that what we have to show? We have to show that dou of u comma v divided by dou of x comma y, equal to 1 divided by 2 a square into cos h 2x minus cos 2y. So we have to prove this. So how to prove this? So first we want to write the formula. So here SOLUN, solution. Our solution is, what is formula? Dou of u comma v divided by dou of x comma y equal to dou u by dou x, then dou u divided by dou y, here dou v divided by dou x into dou v divided by dou y, dou u by dou x, dou u by dou y, dou u by dou x into dou v by dou y, and this is equal to, so here u equal to a cos hx into cos y. Here you have to know one thing, differentiation of cos x with respect to x. Cos x with respect to x is minus minus sin x. Okay, so differentiation of sin x. Okay, sin x equal to cos x, but this is for ordinary trigonometric formulas, sin x and cos x. So this is cyclic functions. Okay, now we are going to find for hyperbolic functions. So we will have d by dx of sin h into x equal to cos h x. There will be no minus, okay. Then in the same way for cos hx also. So d by dx of cos h x equal to sin h x. Okay, so this formula is, these things are very, very important while solving this problem. So here we are having u equal to a cos hx. So a cos hx means u equal to a cos h x. Okay, with respect to x I am going to differentiate. So cos y will act as constant, so we will have a sin hx into cos y. So when I differentiate u with respect to y, a cos hx will be constant, so we will have a cos h x into cos y. Differentiation of cos y is minus sin y. Differentiation of cos y is minus sin y. So minus sin y, and here dou v by dou x. So when you differentiate with respect to x, you will have sin y will act as constant, so a differentiation of sin hx is cos hx, differentiation of sin y is cos y. Now here we will have with respect to y means a sin hx will be constant, a sin hx into differentiation of sin y is cos y. Okay, differentiation of sin y is cos y. Okay, so in the next step we will have this term, the same term only, because we have to bring the minus to the front. So we will have So we will have minus here, we'll have minus here, and this will get cancelled. Okay, this will get cancelled. Okay, this minus term has been brought to the front. Okay, so cos h. So now we have to multiply, that is we have to take the determinant. So how to take the determinant? So these two and minus these two, right? These two minus these two. Okay, so that is what we are going to do now. So here we are having a square sin h square x cos square y. A sin h square x cos square y, then this will become minus and minus will become plus a square then cos h square. We should not write cos square h, we have to write cos h square x into here given with respect to x, then v with respect to, so this is wrong, v with respect to x. V with respect to x means here we have done some mistake, it is sin y. V with respect to x means it is sin y, so here it is a mistake, v with respect to x. How I found this mistake? Because I have to get the terms which will give the square terms combined with sin and cos. So as I am not getting here, I suspect that here may be mistake, and I found that mistake. Okay, so counting mistake is not a crime, but we have to find a mistake. Okay, so a sin h square x cos square y, a sin h square x cos square y, this is our first term, x cos square y plus a. Okay, so this is sin y in the denominator also, it is sin y. So we will have, it is sin y, so it will become sin square y, it will become sin square y. Okay, it is sin square y. So now we have to apply the formula. So one thing is cos square y and another thing is sin square y, and both these are having some formula. In the same way we will have formula for sin h square x, cos h square x, everything. So here we shall take a square as outside, here we shall take a square outside. So if I take a square outside, then we will have sin h square x, sin h square x cos square y, then plus cos h square x into sin square y into sin square y, okay, into sin square y. Now sin square h, sin h square x we are having, cos square y we are having, plus cos h square x we are having, and the sin square y we are having. So I am using the formula for cos square y. So we can write this cos square y, yes, we are going to apply the formula. This cos square y, yes, 1 plus cos 2y by 2. Okay, so sin h square x, sin h square x into the formula for cos square y is, the formula for cos square y is 1 plus cos, okay, 1 plus cos 2y, 1 plus cos 2y divided by 2. Okay, 1 plus cos 2y divided by 2. 1 plus cos 2y divided by 2. In the same way we are having formula for sin square also. So here it is cos, it is cos h square, cos h square x, and for sin square y we are having, instead of 1 plus cos 2y by 2 we are having 1 minus cos 2y by 2, 1 minus cos 2y divided by 2. So 1 minus cos 2y divided by 2, 1 minus cos 2y divided by 2. Okay, so now we are going to multiply this and we are going to simplify this. Okay, our ultimate aim is to get 1 by 2 a square outside, and finally we have to get cos h2x minus cos 2y. So that is what we are going to do. Cos h2x minus cos 2y is what we are going to get. Here we will get a square by 2 into, so a square by 2 into, now we are getting, as I told, a square by 2 of sin h square x into 1 by 2 is taken outside, so sin h square x plus sin h square x, sin h square x into cos 2y plus cos h square x minus cos h square x into cos 2y, so this is equal to sin h square x plus, this can be written as a square by 2 into sin h square x plus cos h square x cos h square x. Then from these two we can take cos 2y common outside, plus cos 2y of sin h square x. Okay, I am adding these two, and as well as I am subtracting these two. That is, I am subtracting both hyperbolic functions. It is circular function or cyclic function. Sin and cos are circular functions, cyclic functions, and sin h and cos h are hyperbolic functions. Now I am adding these two hyperbolic functions here and subtracting these two hyperbolic functions here. Sin h square x into it is minus cos h square x, cos h square x. Okay, now we are having and we will get a square divided by 2 into, so sin h square x plus cos h square x is, so I shall write the formula for sin h square x here. Formula for sin h square x is cos h 2x. Okay, cos h 2x minus 1 whole divided by 2 plus cos h square x is cos h 2x plus 1 whole divided by 2. Then we will have cos 2y into, okay, then we will have cos 2y plus cos, so as cos 2y into, okay, cos 2y into we are having sin h square x minus cos h square x. So we will have the same term here. We will have the same terms there also. So first I shall take this. Okay, I shall place it here. Then it is minus, so minus this term. Okay, so minus this term. Okay, So now we have expanded the above value sin h square x is expanded as cos h 2x minus 1. Cos square x is expanded as cos h 2x minus 1 by 2. One is sin square h square x is cos h 2x minus 1 by 2. Cos h square x is cos h 2x plus 1 by 2. Okay, so we have added these two here and subtracted these two here. Now when we are adding, okay, I am telling everything very slowly. When we are adding, we will have a square divided by 2 into, okay, when we are adding, this minus 1 by 2 and plus 1 by 2 will get cancelled, so we get 2 cos h 2x. So 2 cos h 2x will become cos h 2x. Okay, it is actually, I shall write 2 here. Okay, then it will be easy for you to understand. So it will be 2 cos h 2x 2 cos h 2x divided by 2 plus, here we will get this plus cos h 2x by 2 and minus cos h 2x by 2 will get cancelled, and this minus 1 by 2 and this minus 1 by 2 will become, see, I shall put minus in different color since they are minus. Okay, this whole term, this minus will act on this also, so we will get minus cos 2y plus cos 2y into, so this is minus 1 by 2 and again minus 1 by 2, that is minus 2 by 2 minus 2 divided by 2. So we get the result, that is, what is our result? What we have to prove? We have to prove this dou by we have to prove this, and we have proved. Okay, Ctrl plus C, Ctrl plus V, okay, yes, we have proved this result. We have proved the result. Okay, I hope you all understood the problem. So finally we get of a square into cos h 2x minus cos 2y. So hence the result. Okay, so the problems are not tough. Only thing is you have to know the concept and you have to understand the problem with the formulas required, with the concept we learned, and also by regular practice. Only regular practice will make you to crack any problems. Thank you all for watching this problem. We shall meet on some other problem.